So, I want you to think about this question. Why does heat energy increase as the states transition from solid to liquid to gas? So take a moment, maybe discuss this with someone near you, um, and then write down your answer in a book. Okay, so why does heat energy increase as the states transition? So I kind of hinted at this earlier in the slideshow, but we can think about our states, right? Our solid state, the motion of its particles, right? It does have some motion, some vibrations, right? But compared to a gas, where the particles are flying around and bouncing off each other, there's a lot less motion here than here. And what we need for motion is energy, right? So as we increase the energy in our substance, that allows the substance to have more motion, and that motion is represented in the phase, right? So solids have the least amount of motion going on, liquids have more motion, they can move past each other, the particles, right? And then gas have the most motion. They can escape those forces that are holding them together, and they can fly around the room and bounce off of walls and bounce off of each other, right? So the energy is corresponding to the motion happening inside of each of these states. So the same idea holds true when you decrease heat energy. This means you're taking away the energy, right? So the gas has a lot of energy. We take some away and it becomes a liquid, right? Those forces that want to hold these things together are stronger than the motion of the gas particles now because we've decreased the energy and we get a liquid. Decrease the energy even more, the, the particles slow down and eventually you get a solid, right? So all has to do with the energies of our particles. So here is a table. There's a lot of information on this table, but I want you to get comfortable looking at something like this and understanding what it means. So on the left, we have our substance. So you can see some different substances here. Oxygen, which we breathe, nitrogen, which is in our atmosphere, ethanol, which is alcohol, it's a liquid, water, sulfur, salt, copper, carbon dioxide, right? You've probably heard of a lot of these things. Here we have their physical state at room temperature, so around 25 degrees Celsius. So these are the states that we've learned, right? Oxygen and nitrogen are gases, ethanol and water are liquids, sulfur, salt, and copper are solids, and then carbon dioxide is a gas. Um, and then over here we can see melting points and boiling points. So these are the points where the solids transition to liquids, right? For all of the ones that are um, below 25 degrees, right? That would mean that our substance is either going to be a liquid or a gas at room temperature, which we see is true, right? For all of the ones that are above 25 degrees C, they will be solids at room temperature, which we see here, right? And then carbon dioxide has this A because it actually transitions straight from a solid to a gas, um, which is a special transition that we didn't really cover, but yeah, it is a gas at room temperature. And the boiling points, right, are the point at which the liquid changes into a gas. So again, anything below 25 degrees C should give us a gas at room temperature. You can see that here. Anything above that will be either a liquid or a solid, which we can see here, right? Oh, sorry. So today we learned about the transitions between states, right? You want to know what each of those means. We're gonna do some work now with those words and those vocabulary terms. Um, and I will talk to you next week. Have a great day.